अल्फा कंपनी में काम कर रहे हैं, उसके बाद एक्सपोर्ट इन सोल तो एरिया बोल रहे हैं, आई वेलकम बोल रहे हैं बस। बस ये बोलो 10 years बता के बोलो 7 years 4 years
ఓకే 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 నార్మల్ గట్టి మాట్లాడాలి కదా అందరికీ.
Now, with a great honor, I invite our chief speaker of this day, Miss Apurva Karnam, come on to the dais, who has kindly accepted our invitations. Thank you for this. She has working as in L&T company technology services, and she is also served for the services to the Capgemini with 12 years of experience. So with a big round of applause, I would like to invite Miss Apurva here.
Hello everybody. I would like to start honoring and thanking all the HODs, principal, all the faculty and students. Thanks for the opportunity. Let's start knowing more about cloud services or big data relating to AWS in general, but I would like to focus more on what I have done in my experience in general while going through whatever definitions or whatever services we will learn. I would like to give more information on what were the challenges faced when I was working, rather than maybe giving a definition, because that you would get anywhere in the chat GPT nowadays or Google. So that I would like to give as a information. And let's start with asking a simple question. How many of you think you are using big data in your daily life? Simply you can all raise your hands, or if not you can just be, how many of you think you are using big data in your daily life? It's okay, I'm not your lecturer, I'm not going to scold you if you give a wrong answer. How many of you think you are using big data in your daily life? Okay, so you are not answering because you don't know, or you are not sure? Okay, so each and every one of us who are using Apple Watch, who are using WhatsApp, who are using Instagram, who are using Netflix, everybody of us who are touching a smartphone and using some application which is globally connected, we use big data. So, knowingly or unknowingly, we are all using big data in your everyday life, doing a very small thing to performing very big task, or building our own applications. So, So I'll start. So let's go few steps backwards and try to understand in my perspective how we started using. So we'll go exactly step by step backward and understand in my perspective, in my experience, how we started using big data. So first, so the recent step we are having is big data. Let's go back to on-premise. Let's go back to using a single standalone server. Let's go back to using a manual process and understand how we end up here. So initially, when we were performing all the tasks, for example, as simple as doing some calculations or buying groceries, buying milk, or buying any tickets, community things, or using the hospitals, anything we used to do using a manually. Everything we used to go in person and do it. But there is one other challenge. So we want to track something. For example, we want to track as simple as how many people are present today. So yeah, we can simply take this example of tracking how many people are present today in this college, or how many people are present in the class daily basis, daily noting everything, having a records of hundreds and hundreds pages, and filling buildings with all the papers. And there is also one other challenge is inefficiency. So somebody would always manipulate. We all know there were lots of great scriptures that were lost because they were simply distracted or burned down. So first start I think was to make it organized, because it is simply we can filter the data, sort the data, first keep it organized, accurate, and make it easy. Stop using tremendous work of noting each and everything, and maintaining lot of physical material. So it all started with reducing the physical work and making things accurate, easy for us. And then once we were able to do these basic things online, like buying a plane ticket or buying few type of goods from the online, which if you very go back to some 90s, which were only possible for some certain group of sophisticated people who were able to access the internet, able to access the mobile, right? So from there too, we all got access to internet. Then what started as just reducing a manual process and making accuracy became convenience. Now we are not doing something just to do it accurately or do it reduce the physical labor. We are doing just for the convenience. We can just go out of our building and buy a milk beside a shop beside our home or something, but no, we are still using a Blinkit or Swiggy. So it became a convenience. And then we all the apps came up: Swiggy, Blinkit, Amazon, all the groceries. And you cannot say that these are confined to only this uh, convenience things. It also helped us to really help in the all different domains like health sector, banking sector, uh, or if you say tracking the government policies, regulating the government policies. And you name a domain, or it is helping in a lot of industrial areas, analyzing the data. It helps us in a different domains. Okay. And what, so after that, now we are in the point where we got lot of data, so people started using the apps. So we got lot of data where we are now noting and storing the data, who are buying what, when they are buying, how they are buying, at which place they are buying. So now, since we got the data, lot of people are using, now we are using the data to do the prediction models. So now we are using data and sending creating a models which are used by the machine learning models, or we can simply do a simple dashboards, understand the graphs, organize the data, and we can simply see that and create a solution which will help us to solve a lot of problems. Okay, and then now we are in the point where we are using lot of applications, we are using the data from the application for lot of use. Then we are in the next step. No, the data is so huge that we are not able to handle that with a single server or single set of servers there. It is happening in a at every milliseconds we are storing, simulating or manipulating lot of data at every millisecond, that a small storage system is not enough for us. Many megabytes, pegabytes, terabytes of the data is exchanging every millisecond. So now the big data came into the picture. Let's scroll down. Big data came into the picture, which will help us to handle the very huge amount of data easily and run the applications very smoothly. For big data, the main examples we can say are Instagram, Netflix, anything. Okay. So, okay, fine. So just since we had a great start of how things started and how things are going, we will understand how this concept of collecting the data, using it in a prediction model, and now starting using the big data, or if you can say one step ahead, using a cloud services will happen in the real time uses. For example, I'll take a project I'm working on. Okay, so I'll start. I start by introducing what I have worked on. So I have worked on Java full stack development. So if I am not sure how many of you are already aware of it, but what is Java full stack development or any other full stack development is any set of technologies which include front-end technologies, back-end technologies, middleware, and cloud technologies. Then, if somebody are decently aware of all the technologies, they can be termed as Java full stack developer. And of course, if in the real case, it doesn't mean one person will do everything. Of course, he will hold a knowledge on the back end, front end, and middleware, and mostly in lot of cases, the cloud computing part or usage of cloud will happen with a specific people called DevOps. So they will be a person who will take care of creating services, how to handle that. Okay. So along with that, I also have worked on Node.js. So Node.js, if you see, yeah, this we have, of course, we are using big data and all this for the cloud area. But if I'm talking about the technology area, Node.js is now booming so much because it is so lightweight. You don't have to run a very heavy Java project or any .NET project to build an application. If you understand that your application is a small and flexible application, you can prefer with a Node.js technology. Okay, and then so what we do in a so I recently have worked on a project called crowd detection analysis, and we have done that in the Tirumala Tirupati Devasthanam. So what it does is it will collect the data. So we started So we just discussed the starting part of any application will be UI. So that will be the user, user who is using the application, whatever you see in your in your computer, the front face. But in general, in a software point of view, or as I understand, there will be always one step ahead from what you are getting the data. So in our case, we will get the data from a lot of data, not just by user, but also from the different uh, electrical sensors or cameras, or we can say any prediction models. Okay, we will get the data from those from those cameras, and we will take it as an input, and we will do some dashboards. Dashboard, I am using the term dashboard so much, because it is a one of, so whatever the data we are collecting from, take it as a user or from electronic devices, the major use case in the real world is making a dashboard. Dashboard is nothing but a simple report, you can say. We can create a dashboard using a Power BI tools or Grafana. So it's a simple querying the data, whatever data we have, and creating the reports. So what is the use of those reports? So using that reports, we can clearly understand what are the graph of the data that was used, at what time it is used, what are the users that are using that data at what time, and what are the so for example, if we take we are doing a crowd detection, for example in our college, so we will have a cameras in the multiple places. For example, entering of our college, exiting of our college. So I'm converting the example in the college, because it will be maybe easy for you to understand, right? So, for example, we are doing a crowd detection analysis in our college. We have decided to do that. So, what we'll do, we'll have cameras on the major areas. Okay, we'll have it in the labs, we'll have it in the entrance of the college, we will have in the seminar halls. Okay, or we will have in the areas where students are prohibited. So so that we can understand if there is lot of crowd there or not. So we will have that all those cameras there, and we will get the data from all those cameras or electronic devices. We can get that data in the form of JSONs or APIs, right? We can get that APIs, and we can store it in our own applications, right? And we can do a simple analysis with that data, and we can clearly have a dashboards for each every place. For example, I can simply filter the data and bifurcate it in how many people are present in the area. For example, there is a restricted area 1. So I can simply see the amount of people present in the restricted area 1. If there are more than 5 people, I can simply understand that, okay, there is some problem there, and I can go and regulate it. So that way it is useful for me to understand where is the problem, detect the problem, and regulate it. In the same way, so dealing with the crowd analysis in some place like Tirumala Tirupati, or in especially in case of Brahmotsavam, is not easy, because any small mishandling of the crowd analysis would really lead to the lot of um injuries to the people, or not properly handling the crowd will really be a issue. So we will have all these detection models, and we will analyze, and we will quickly take a decision. We will quickly take a decision to migrate people to in a different direction, or police will quickly go there and handle the situation. That is the first thing we will do. And what is the second thing? One, even so, it's not always about what we are doing at that spot. It is also that we are having the data and how we are using for the next decisions. So the one thing I observed in my work experience is, even when we are initially starting working, the data we get will be sometime inefficient or not accurate. But we will never delete a single record of data, because data is always crucial. So at the end, if you boil down everything we are doing, it will come to the boiling point of data, right? So every data we are having, every single record we are having, from the very starting of any analysis to what is happening to that point, we'll take the every data, do analysis, and we will take a next steps how to help it, and how to help us build a better structures, right? So if you are if you are observing, and uh, uh, if you are observing some misplace of students, and people, like maybe there is some short wall there, and the students are climbing over it and leaving the college, we can detect that and we can understand the problem, and we can maybe do a small remodelation and make the people, everybody in the college. So those small changes we can do. Or in case of uh, if there is a small mouth point, so whatever the, for example, the person standing here, it is an entrance, generally we call it as a mouth point. Mouth point is nothing but the place where people are coming in a huge case. So in case of a temple premises or any public area, the data, whatever the data is happening at the mouth point is very important, because if you are not regulating what the data is coming at the mouth point, and if there are very huge crowd coming at the mouth point, it's like you can simply understand it in the form of a pipe having a hole. So if it is not correct, it would burst out and break the whole pipeline, right? In the same way, if you're not regulating here properly, people would just burst out and go out, and they would hit each other, and injuries may happen. So basically we do all these analysis of making a decision in the current moment, and understanding that there is a problem at specific point like mouth points or some area, and rebuild the structure, rebuild our whole structure such a way that we are building a overall efficient model which will help us to avoid failures or provide the efficiency. Okay. PPT. So, okay. So, first we will understand why we use AWS, right? So instead of using a physical server, we use a server in a online form, in a cloud. We access the server using a internet. That is that one form we can achieve using AWS. Okay, we'll go one step before and understand why we need servers in the first place. Forget about AWS, forget about big data, forget about everything. Why we need a server in the first place, right? Okay, we already got to understand that we want to do things accurately, we want to avoid the physical work, we want the convenience. So one thing is sure, that we want to use lot of applications and lot of websites. That in the first place is done. So now you assume you are using your own laptop and building a website or application. What you'll do, only a single person can use the application, right? Or if you shut down your laptop, nobody can use it. So as I understand, so there might be different ways to understand something, But in my experience, I understand anything. It can be a server, may it can be a AWS model, or may it can be a big data. You can understand something based upon this few parameters, that is availability. Next one is scalability. Third one is security. Fourth one is pricing. You can just understand these four parameters, and you can just keep in mind of these four parameters and understand any model with these four parameters, right? First, we'll come with first one. So what is the problem with using some simple local host or local laptop? Availability. So if your single laptop is switched off, you will not able to access the website, right? If you are normally building in your own computers, it will be not available. Next one is scalability. So if you started using the app, you have used lot of storage, you now want to increase the memory of it. So you can't keep on adding the physical drives to it, right? You can't do it. Next one is security. So we can't guarantee a security of your laptop to a big projects. Third one is pricing. So we don't even have to think about pricing, because using a local host or a single laptop will fail on first few models of availability and scalability itself. So now we will start using a server, right? What is a server is nothing but it's just a simple physical device. You can understand it is as a your computer, but it is always ran. It is always working, right? Always on. So it's a physical server which is always available, and it will help us help multiple people from the multiple locations to access the application at the same time. So that we are achieving using a server. So now we have solved the one basic problem of availability. We know, so we can't say completely, but at one point we have solved the problem of availability, right? And next one is scalability. So yeah, we can increase the sizes in the so we'll start initially with some memory in the server, and we can scale it also. But if you are strictly considering a physical server, it is really hard. We can't achieve a scalability in the physical server. The third one is security. So we can combinedly understand the problem of availability and security here. So for example, we are using a physical server, and something happened to that server. For example, uh, so the thing with the physical server is you have to maintain the physical server. You have to do the maintenance of that. You have to check the availability of it, the working condition of it. So so if, or you, there might happen a physical damage to the server. In that case, you are losing the data in the physical server, you are losing the availability of the physical server, and it is not, you are also responsible for the physical server. And pricing. So see, if, so for application, you have to buy a whole physical server. Though if the application is using 24 by 7 or not, if you are buying a physical server, you have to maintain it. There will have the lot of maintenance cost. There will though for example you are using a physical server of consider 5 terabyte, and maybe you are hardly using half terabyte, but you are still paying the cost of 5 terabyte. So that is literally lot of disturbance or gap we see in the physical server, right? We are paying something which we are not using for, right? And the third one is security. So security is always, see, we can provide the security for it, we can maintain it, but it is always, there is always little risk in having a physical server. So all this, yeah, we have talked about all this: the scalability, security, downtime in case of damage, cost. So all these are the challenges in the traditional setup. So, so all this will happen in the physical server. But now, if you understand the uh, cloud computing, so this physical server, what we are talking about, this we can access using a internet. We can access a server. So what are the advantages here? So what all the physical servers does, a cloud computing server does that, along with what are all the disadvantages or what are all the drawbacks we have in the physical server, those are also covered in the cloud computing concepts of the server. So we will understand this in the same format like availability. So we can have a cloud computing server, and we can have it always available. And the one advantage of it is, if you are using something like a lambda, we can pay as you use. So if you can decide that I'm using a server for only 1 hour per that day, you can pay only for 1 hour, or you can decide a pricing in the form of data. You can say that I'm using it only half GB overall, you can pay for that. Next one is security. So compared to the physical server, it is always secure. Even we are not we are not worried about the data storage or physical damages, both in case of the cloud computing. If you understand scalability, so in scalability is the most advantage here, because so we are not bothered about adding the physical server one upon the other, or one upon the other, how to maintain it, integrate it. We are not worried about. We can simply scale and manage it within maybe a simple clicks, and we can increase our storage of maybe 2 terabyte to 5 terabyte very easily without disturbing our existing architecture. That we can do. Yeah. So I would like to explain it is in a simple analogy where we can understand what is a physical server. Is It's like a, so we are not generate. It's like simple analogy to help us understand what is a cloud computing. Like, instead of generating our own electricity or something, we are simply renting it. So you can simply understand it as a current bill, right? You are not always paying all the price for current generated in the whole power plant, right? You are paying the bill for how much you are using in your own house, how much amount of voltage or current we are using in form of quantity, you say, or in form of time, you say, that we are paying as we use, right? That is the advantage of a cloud computing. So if you can quickly see that cloud computing is not just for storing the data or launching our application there. We are using cloud computing for managing our application, storing our data, handling our encryption, handling our accesses, right? We will quickly talk about a few things. For example, uh, you are, so how you will do a authentication of a simple application? Okay, how you will build a application? In the first case, you will have a login page, you will have home page, then you will have a list of services you are using. It is a simple model. You take smallest application to the biggest application and built till now. This is a simple model of login, homepage, what are the services you are providing, and what are and maybe some new features which are their expertise or they want to offer, right? So first we'll come to a login. So there are different ways to authenticate the login. For example, we will use different ways like JWT token, auth2 token, or we will use base 64 model. These are simply nothing but depending upon our login, they will provide a encryption logic. Okay, but at the end, once you are giving a password to a website, it will store in our DB. Or for example, we want to access some external application in our DB, right? uh, in that case we are storing our very secured passwords. Or so so normally when you start working in a real time project, you will understand that it's not, see, for example, started working on a project or building something, you will not do each and everything by yourself. You want a data for a data from a physical device, you will have a vendor. So somebody who will give us the details, who will do some other background work and give us the details, we call them a vendors. Somebody who we are working for are called as clients. So these are the real time words we will use. And once we build the project, who are actually using the application, they are called users. Okay, so when we are using a vendor data, or when we are using data from some other very secured place, we can't simply store our project details or passwords, those links directly in our YAML file. So we can call a YAML file, or we can in case of node we can call a .env file and simply put it in the git and let it open to the world and let them hack it, right? We can't do that. So what we do is, as a basic example, the or in our old model we use a simple base 64 concept. We decrypt it and store it. And if it is very important and we are start using cloud, we will use something called a system parameters. So there encryption happens. So we will encrypt that using the AWS models, and we will store that in, for example, we can call S3 buckets. And these AWS models will have very strict inbound and outbound rules. What are inbound and outbound rules? This is very important to understand, because inbound is inbound and outbound rules are, we will clearly configure what are all the applications or devices that we are allowing our application to use. And outbound rules are what are all the applications we are giving the data. So it is very strictly configured who exactly we are. Even so, it's not like, so it's our application, I can use the data from anywhere. No, we should not, even though it is free, we should not use data from any random person or any random application or any random vendor to our application and use that data. Because using it, so though we are using that data and building something, it may cause a security breaches. So we have to be very careful and configure the inbound rules also, and only use the data from the secured places, and the vendors we are using from, and whom we are whom we are allowing the data to access. So we will strictly configure what are the IPs, what are the range we are allowing the data from our application, we are allowing to use, right? So we are allowing who we are using the data. So we can do this configuration in our normal on-premise server also. In case of AWS also, we can do that in the AIM servers which is provided by AWS. We can store our files in the S3 bucket, and we can configure it, and we can strictly confine our secured data in our application. So other things we can know more details about here are about data migration. So we will take one example of data migration, and understand what will the challenges you will face in the real world, and how cloud helps us in that. For example, if you are data migrating inside cloud, for example, you say EC2 to some other different model, that is also easy in the cloud services. Or for example, you take a physical server. So each physical server will have a specific IP, specific subnets, and see, we assume something happened to that physical server, or the vendor or some person who are providing the data for us to that physical server, he is not able to provide that data to that specific IP. Assume that. So now what we have to do? Now we have to assign a different physical server, and now we have to use that server no. So for that, what we have to do is we have to literally configure our whole application from that server to the new server, and migrate the data from one server to other server, which is very tedious and hard process. But that can be easily achievable in the cloud. Okay. So before going to that, so now that we have heard lot of things about cloud in general, do you think it's only AWS? So going further, all the applications will start using only AWS or Azure per se, or only some cloud services, and not using a physical server only? Can anybody answer? Do you think so? What do you think is happening now? So currently, while we are here, what do you think? All the big companies, all the applications we have, are everybody are using cloud now? Nobody are using physical server. Everybody are using cloud. Do you think that is happening currently?
Yes.
It's okay. You can answer. What is happening now? What do you think is happening now? So I'll try to answer from my experience and my knowledge. What is we'll discuss about. మీరు ఇది చెప్తేనే వెళ్తారు లంచ్కి, లేకపోతే వెళ్ళరు. We will discuss two things, and we'll go to lunch. One thing is what is happening now, and what do you think will everybody will start using a cloud service and stop using a physical server. We will discuss these 2 points and we'll leave. Okay. Let's somebody answer. Do you think currently, as we speak, or so for, okay, forgot about the small companies, the major companies or major applications, do you think everybody are using cloud?
Yes.
Everybody, literally everybody.
Yes.
So I would prefer to say no. Okay, that first answer for this, no. And second question, do you think everybody will start using cloud services in future?
Yes.
Everybody. I would say no to that also. Okay, we will so this point we'll discuss. This is important because you don't have to be in this whole thing of it's all cloud. No, doesn't mean cloud will start. Doesn't mean cloud will stop. Who want to use cloud, you will still start using cloud and start using cloud very vastly, but there will be still applications which will use a physical server, and there will be still very big applications that will in future also start use physical server. Why, we will discuss. First thing is requirement. So I'm working for a small bank, very small bank, oh, forget about small bank. In real world, do you think you will only have some banks like what do you say, SBI, or I don't know, HDFC? These are all big banks, right? So in real world, if you see, there will be banks in between companies also. So I worked in a banking company, which the banking transactions won't happen between the people, it will happen between the companies. So one company will, I'm not naming things because I don't know, maybe it's all secured, right? So we will speak real time things in general, right? Okay, a big company will transact money, so there will be a sister companies, by you mean say, for example, you take Tata. There are hundreds of companies in the Tata, right? So one small company in the Tata will do a transaction from the other company of a Tata. So if you say, though those are internal transactions, those are very huge transactions or data happening there, though, so they will still use a cloud. But we will assume we are using a small, using, though it is a very important application, it is a small application. Or we can assume a situation where we know what we are able to validate what is the traffic to that application, how much of the data we will use, how much of the RAM we will use, how much of the pricing we know. We have a clarity on that, right? We have a clarity on the scalability, right? And for example, we can, so same, what I'm trying to say is with the same things of availability, scalability, pricing and security. So I have a clarity on what is the scale of application. I'm very clear upon that. So or what is the traffic of an application. So for example, I'm building an application which I'm very sure that only 1 TB of a data will be used and my service for the application will be 5 years. So do you think, should I still use a cloud? May or may not be. And for example, I'm a company which already have a servers, right? So one thing to be clear, that every company will always have a server room with set of servers. So for example, I already own a server. I'm talking about today. Today I own a server with me which is 5 TB, which is perfectly working condition, which I am very sure that it will work for the next 5 years. Okay, I'm a company. I have a server which has 5 TB of data, which is in perfect conditions and which will definitely work for 15 years. And I got a requirement from a vendor, which I'm clearly able to validate they will not use the data more than 5 GB, and I have to provide them a service for the 5 years. So what we are saying here, we are saying the availability, we are saying the pricing, and they are not maybe able to provide me lot of cost which I will use to build a cloud services. Do you think should I still buy a cloud service? Not needed, right? Because I hold a physical server. I'm talking about today, right? So in the so basic decision we will take based upon the what we already have in my hand. In my office I already have, so we can simply call it a requirement. What is a requirement I'm having? What is client asking? So for example, tomorrow one person will one client, company will come to me and ask, I need an application which will run only for 1 hour a day. That's enough for me, right? uh, or somebody will come and okay, or there is one concept in this corporate world called social corporate relations. So they will do some free projects, and I already hold a server. So for that I won't buy a cloud services, right? No, I won't buy. I will use a server which is in my server room lying around, right? So to be simple, we'll take a decision based upon what is their availability, what is the scalability, what is the pricing they are able to provide, and what is the security. If I am able to provide the security, depending upon this decision, I will take the decision. Now let's come to the future. So you can say that all the servers I have in my server rooms, all which are already present, maybe, or I'm starting something new, and I'm not holding a server already. I have built a new company. I have built a new company which is also very huge. You assume I have built a multinational company which is very huge. I'm able to handle very huge projects. I'm not holding a physical server, but there is one case I will still not use cloud. Can you try and answer the question? It will lie on those 4 parameters only. Money is not constraint for me. Availability is not a problem for me. Scalability is not a problem for me. But I will still use a physical server. You can just take a guess. Why will I choose a physical server still?
Security.
Security. Correct. So you assume it's all hypothetical, okay? You assume ISRO is making a, yeah, you can take ISRO is making a, or you can say something like ISRO, some NASA, ISRO, something is making a something. So I'm naming this big ISRO or NASA because the data coming from that specific type of applications is very, 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 very secured, very important to us, and we will be very conscious for the data to be leaking from one country to other, right? See, even one mismatch of the data happens between leakage of a data happening between the countries also, it will be very hard for us. Or for example, I'm building a very highly secure data, uh, hypothetical, I'm building a data for my country India, which holds a all the details of security systems we are building for, um, assuming protecting some, I don't know what is very important to us, maybe some monuments, right? Which is where we are building a security system for monuments, or no, we are building a security system for nuclear weapons, assume. So, will I still trust a US based company, AWS, to store this data? I'm building building something for India. No, right? We will never do. So we will never take that risk. See, will always have discussion relations. Even in now, we are using lot of a lot of applications from different countries to us. It's all secured. It is all. We'll have a policies. We'll have everything. We will make sure, though we are using the data from different countries or something, we'll make sure everything is secured. But you understand that if you are considering our data is very important to us, we will never trust some other countries or some other ex-person. We will always make sure, even it will take extra effort to maintain my server, it will take extra effort to store my data. We will all compromise on everything, and we will choose the security over it and maintain my data. That's all. Thank you.